Close your eyes for a moment and imagine floating in the infinite expanse of space, where darkness stretches endlessly, yet is punctuated by the gentle glow of countless stars. Each one, a beacon of light, tells a story of birth, life, and eventual transformation. Tonight, we embark on a journey through time, tracing the life cycle of these celestial wonders, from their first whispers in the cosmic nursery to their final, breathtaking farewells. Stars are not just distant lights in the sky, they are the architects of the universe, shaping the very fabric of existence. As we drift through this cosmic tale, let the soothing rhythm of the stars guide you into a state of calm, where the mysteries of the universe unfold like a lullaby. What if I told you that every star you see has a story as unique as your own? Stay with us, and together we'll uncover the timeless beauty and profound mysteries of how stars are born, live, and eventually fade into the cosmic tapestry. Where are you joining us from tonight, and what time is it there? Let the stars be your companions as we begin this journey through the universe. Now, let us drift deeper into the heart of the cosmos, where the story of stars begins in the most serene and mysterious of places, stellar nurseries. Picture vast, ethereal clouds of gas and dust, drifting lazily through the galaxy like cosmic brushstrokes on an infinite canvas. These are the birthplaces of stars, where the universe quietly weaves its magic. Within these clouds, gravity, the silent sculptor of the cosmos, begins its work. Slowly, almost imperceptibly, it pulls the gas and dust together, gathering them into denser clumps. Imagine the gentle swirls of color, like watercolors blending in slow motion, as these clouds begin to collapse under their own weight. Here, in these cosmic cradles, the first whispers of a star are born, a faint, glowing ember hidden within the darkness. It's a place of quiet creation, where the universe hums with the promise of new light. As you envision this serene process, let the gentle movements of these swirling clouds lull you into a deeper sense of calm, as if you're witnessing the universe's most delicate dance. As the cosmic clouds continue their gentle collapse, we now turn to the next chapter in this celestial story, the birth of protostars. Within the heart of these swirling clouds, the gas and dust grow denser, pulled ever closer by the unyielding force of gravity. As the material compresses, it begins to heat up, like a warm glow slowly spreading through the darkness. This is the moment when the first glimmers of light emerge, faint and delicate, as if the universe is whispering its secrets. Imagine a tiny, glowing core forming at the center of this cosmic cradle, a spark of potential hidden within the vast expanse of space. This is the protostar, the earliest stage of a star's life. It is not yet a star in the full sense, but a promise of what is to come, a beacon of light in the making. The heat builds as the core grows denser, and the faint glow begins to brighten, like a candle flickering to life in the quiet of the night. This process is slow, almost imperceptible, unfolding over thousands of years. Yet, in the grand tapestry of the universe, it is a moment of profound transformation. The protostar is a bridge between the darkness and the light, a fragile yet powerful reminder of the universe's ability to create beauty from chaos. As you picture this glowing core, let its gentle light guide you deeper into the story of stars, a tale as old as time itself. And now, as the protostar begins to shine, we move closer to the next stage, where gravity and heat will dance in perfect balance, shaping the star's destiny. Now, as the protostar begins to take shape, we witness the delicate interplay of forces that will define its future. Gravity, the unseen hand of the cosmos, continues to pull more gas and dust into the growing core. This relentless tug draws material inward, compressing it further and raising the temperature at the heart of the protostar. Yet, as the core grows hotter, a new force emerges: heat. The energy generated by this rising temperature begins to push outward, creating a counterbalance to gravity's pull. This cosmic dance between gravity and heat is a delicate one, a harmony that must be maintained for a star to form. Imagine gravity as the conductor of an orchestra, guiding the flow of material inward, while heat plays the role of the musicians, resisting with their radiant energy. Together, they create a symphony of forces, each note perfectly timed to sustain the star's growth. As more material is drawn in, the protostar's core becomes denser and hotter, reaching temperatures that begin to ignite the first sparks of nuclear fusion. This is the turning point, where the balance between gravity and heat becomes even more critical. Too much gravity, and the star would collapse under its own weight. Too much heat, and the material would scatter, never forming a stable star. It is this precise equilibrium that allows a star to shine, a testament to the universe's ability to create order from chaos. Picture this process as a cosmic ballet, where every movement is calculated, every step deliberate, ensuring the star's birth is both graceful and enduring. And so, as gravity and heat continue their eternal dance, the protostar grows brighter, inching closer to the moment when it will truly become a star. This balance, this harmony, is the foundation of stellar life, a reminder of the delicate forces that shape the universe. With this balance in place, we now move closer to the next stage, where the star's core will ignite, and the universe will witness the birth of a new light. As the cosmic ballet of gravity and heat reaches its crescendo, we arrive at the defining moment, the birth of a star. Deep within the protostar's core, temperatures soar to unimaginable heights, reaching millions of degrees. At this critical threshold, something extraordinary happens. The intense heat and pressure force hydrogen atoms, the simplest and most abundant elements in the universe, to collide with such force that they fuse together. This is the moment nuclear fusion ignites, and a star is born. Picture this: hydrogen atoms, once drifting freely in the vastness of space, now come together in a fiery embrace. As they fuse, they form helium, releasing a tremendous burst of energy in the process. This energy radiates outward, flooding the star's core with light and heat. It's as if the universe itself has lit a candle, a beacon of warmth and brilliance in the cold, dark expanse of space. This first burst of light is not just a spark, it's a declaration. The star announces its presence to the cosmos, a radiant testament to the power of creation. The energy released by fusion pushes against gravity's pull, creating a stable balance that allows the star to shine steadily. This is the moment when the protostar transitions from a glowing ember to a true star, a celestial body capable of illuminating its corner of the universe for millions, even billions of years. Imagine the star's core as a cosmic furnace, where hydrogen atoms are the fuel and fusion is the flame. With each collision, more energy is released, feeding the star's glow and sustaining its life. This process is not just a scientific marvel, it's a poetic reminder of the universe's ability to transform simplicity into brilliance. As the star begins to shine, it casts its light across the surrounding gas and dust, illuminating the remnants of its birth cloud. This light carries with it the story of the star's creation, a tale written in the language of energy and matter. And so, with the ignition of fusion, the star takes its place in the cosmos, a radiant symbol of the universe's endless cycle of birth, life, and renewal. With this newfound light, the star embarks on the next phase of its journey, entering the main sequence, a period of stability and steady brilliance. But for now, let us pause and marvel at this moment of cosmic ignition, when a star is born and the universe gains a new source of light. As the star settles into its newfound radiance, it enters a phase of remarkable stability, the main sequence. This is the longest chapter in a star's life, a period where it shines with a steady, unwavering glow, like a cosmic heartbeat echoing through the ages. Here, the forces of gravity and fusion reach a delicate equilibrium, a balance so perfect that it allows the star to burn brightly for billions of years. Picture the star's core, a bustling hub of activity where hydrogen atoms continue to fuse into helium, releasing energy with every collision. This energy flows outward, layer by layer, until it reaches the star's surface, where it escapes into space as light and warmth. It's a process as reliable as the rising and setting of the sun, a rhythm that defines the star's existence. During this phase, the star's size, temperature, and brightness remain remarkably constant. It's as if the universe has pressed pause, allowing the star to bask in its own brilliance without interruption. For stars like our Sun, this phase can last for around 10 billion years, a span of time so vast it's almost impossible to comprehend. Yet, even in this stability, there's a quiet beauty. The star's light becomes a constant companion to any planets that may orbit it, bathing them in warmth and nurturing the potential for life. It's a reminder that even in the vastness of space, there are moments of enduring calm, where the universe seems to hold its breath, content to let the stars shine on. As the star continues its steady burn, it becomes a beacon of constancy in an ever-changing cosmos. Its light travels across the void, carrying with it the story of its birth and the promise of its future. And so, the main sequence becomes not just a phase, but a testament to the star's resilience, a quiet yet powerful reminder of the universe's ability to create and sustain. With this steady glow, the star prepares for the next chapter of its journey, a transition that will come not with a sudden burst, but with the gradual exhaustion of its fuel. But for now, let us marvel at this enduring light, a symbol of the universe's quiet strength and timeless beauty. As the steady glow of main sequence stars fades into the background, we now turn our gaze to the dazzling array of stars that fill the cosmos. The universe is home to a breathtaking variety of stars, each one unique in its size, color, and temperament. From the faint, cool whispers of red dwarfs to the blazing brilliance of blue giants, the stellar population is a tapestry of light and energy, woven together by the forces of nature. At the heart of this diversity lies a star's mass, a single characteristic that shapes its entire existence. A star's mass determines not only its color and temperature, but also its lifespan, creating a cosmic spectrum of possibilities. Smaller stars like red dwarfs are the quiet, enduring members of the stellar family. These stars burn their fuel slowly, glowing with a soft, reddish hue that can last for trillions of years. Their gentle light may not command attention, but their longevity makes them the unsung heroes of the galaxy, quietly illuminating the cosmos for eons. In contrast, the massive blue giants are the rock stars of the universe, bright, bold, and short-lived. These stars burn through their fuel at an astonishing rate, shining with an intense blue-white light that can outshine entire galaxies. But their brilliance comes at a cost. With lifespans measured in mere millions of years, these giants live fast and die young, leaving behind a legacy of light and energy that shapes the universe around them. Between these extremes lies a spectrum of stars, each with its own story to tell. Yellow stars, like our sun, occupy a middle ground, balancing brightness and longevity in a way that nurtures life. Orange stars, slightly cooler and dimmer, offer a warm, inviting glow, while white stars burn with a pure, steady light. Together, these stars create a cosmic mosaic, a living gallery of light that spans the ages. The color of a star is more than just a visual trait. It's a window into its inner workings. Cooler stars, with their reddish hues, burn at lower temperatures, while hotter stars glow blue or white, their surfaces searing with energy. This interplay of color and temperature is a reminder of the delicate balance that governs the universe, a balance that allows stars of all sizes and colors to shine in harmony. As we marvel at this stellar diversity, we are reminded of the universe's boundless creativity. Each star, no matter its size or color, plays a vital role in the cosmic story, contributing its light to the grand tapestry of the night sky. And as we continue our journey through the life cycle of stars, we carry with us the knowledge that even in the vastness of space, there is beauty in every form, a testament to the universe's endless capacity for wonder. With this understanding, we prepare to explore the next chapter in a star's life, a phase where even the most stable stars begin to change, their light shifting as they enter a new stage of existence. But for now, let us pause and appreciate the stars in all their varied glory, a reminder that the universe is as diverse as it is beautiful. As the tapestry of stellar diversity unfolds before us, we now turn our attention to a profound transformation in the life of a star, the gentle expansion into a red giant. This phase marks a pivotal moment where even the most stable stars begin to change, their light shifting as they enter a new stage of existence. When a star exhausts its hydrogen fuel, the delicate balance between gravity and fusion begins to falter. The core, no longer able to sustain the outward pressure of fusion, starts to contract under the relentless pull of gravity. This inward collapse generates intense heat, causing the core to grow hotter and denser. Meanwhile, the outer layers of the star, no longer held tightly by the core's gravitational grip, begin to expand outward. Like a cosmic flower, Blooming in slow motion, the star swells to hundreds of times its original size. Its surface cools as it expands, shifting from the bright, steady glow of its main sequence days to a softer, reddish hue. This transformation gives the star a new identity, a red giant, a gentle giant of the cosmos. The process is both beautiful and inevitable. As the star's outer layers drift further from the core, they create a vast, luminous envelope that glows with a warm, inviting light. This expansion is not chaotic but graceful, a testament to the star's resilience as it adapts to the changes within. Yet, this phase is not without its challenges. The star's increased size and cooler surface temperature mark the beginning of the end for its stable existence. The core, now burning helium instead of hydrogen, continues to contract, while the outer layers grow more diffused. This delicate dance between contraction and expansion sets the stage for the next chapter in the star's life, a chapter filled with both brilliance and transformation. As we witness this gentle expansion, we are reminded of the universe's capacity for change. Even in the face of inevitable decline, stars find ways to shine in new and unexpected ways, their light a reminder of the beauty that lies in every phase of existence. And as we continue our journey through the life cycle of stars, we carry with us the knowledge that even in the vastness of space, there is grace in every transformation. With this understanding, we prepare to explore the next act in a star's life, a phase where the core's burning helium gives the star a temporary resurgence of energy, a second act in its cosmic story. But for now, let us pause and marvel at the red giants, their gentle expansion, a reminder that even in the face of change, there is beauty in the unfolding. As the red giant continues its graceful expansion, a quiet yet powerful transformation begins deep within its core. Now turning to the heart of this cosmic giant, we witness the ignition of a new chapter, helium fusion. This process marks a second life for the star, a temporary resurgence of energy that breathes new light into its existence. Within the core, the intense heat and pressure generated by the collapse of hydrogen fuel now reach a critical threshold. Helium atoms, once inert, begin to collide and fuse, forming carbon. This fusion releases a burst of energy, reigniting the star's inner fire. For a time, the core stabilizes, balancing the outward pressure of helium fusion with the inward pull of gravity. This phase is a delicate dance, a cosmic balancing act that allows the star to shine brightly once more. The energy produced by helium fusion radiates outward, warming the star's vast outer layers and sustaining its luminous glow. Yet, this resurgence is not eternal. The core's helium supply, though substantial, is finite. As the star burns through this fuel, it prepares for the next stage of its journey. The process of helium fusion is a testament to the star's resilience. Even as it approaches the twilight of its life, it finds a way to shine with renewed vigor. This second act is a reminder that even in the vastness of the universe, there are moments of rebirth and transformation. As we observe this phase, we are drawn into the quiet rhythm of the star's existence. The steady burn of helium fusion, the gentle expansion of its outer layers, and the warm glow of its light all tell a story of endurance and grace. And as we continue to explore the life cycle of stars, we carry with us the understanding that every phase, no matter how fleeting, holds its own unique beauty. With this newfound energy, the star moves closer to its final acts, where its outer layers will drift away, leaving behind a glowing remnant of its once vast form. But for now, let us marvel at this second life, a brief yet brilliant chapter in the star's cosmic story. As the star's helium fusion begins to wane, a new and breathtaking transformation takes center stage. Now entering the twilight of its existence, the star prepares for its final act, a cosmic farewell that will leave behind a stunning legacy. This is the stage of planetary nebulae, where the star's outer layers gently drift away, creating a luminous tapestry of light and color. The process begins as the star's core, now rich with carbon, can no longer sustain the balance between gravity and fusion. With its fuel nearly exhausted, the core contracts, while the outer layers expand and cool. These layers, once part of the star's fiery embrace, are now gently pushed outward by the radiation from the core. Slowly, they begin to drift into the surrounding space, forming a glowing shell of gas and dust. This expelled material, illuminated by the fading light of the star's core, creates intricate patterns that shimmer and dance across the cosmos. Swirls of red, blue, and green paint the darkness, as if the star is leaving behind a final masterpiece. These glowing clouds, known as planetary nebulae, are among the most beautiful sights in the universe. Their delicate shapes, rings, spirals, and even butterfly-like forms tell the story of the star's final moments, a story written in light and gas. The beauty of a planetary nebula lies not only in its appearance, but also in its significance. This cosmic farewell marks the end of a star's life, but it also serves as a beginning. The elements forged within the star, carbon, oxygen, and others, are now scattered into space, ready to become part of new stars, planets, and perhaps even life. In this way, the star's final act is also a gift to the universe, a contribution to the endless cycle of creation and renewal. As we gaze upon these glowing remnants, we are reminded of the fleeting nature of existence and the enduring beauty of transformation. The star's journey, from birth to this luminous farewell, is a testament to the resilience and grace of the cosmos. And as we continue to explore the wonders of the universe, we carry with us the understanding that even in endings, there is beauty, purpose, and the promise of new beginnings. With the star's outer layers now adrift in the void, its core remains, a dense and fading ember. But before we turn to this final remnant, let us take a moment to appreciate the serene beauty of the planetary nebula, a cosmic farewell that shines with the light of a life well lived. Now turning to the quiet aftermath of a star's luminous farewell, we find ourselves gazing upon the remnants left behind, white dwarfs. These dense, Earth-sized cores are all that remain of stars like our Sun, after they have shed their outer layers in the form of planetary nebulae. Stripped of their fiery envelopes, white dwarfs are no longer powered by fusion. Instead, they glow faintly with the residual heat of their once brilliant cores, like the last embers of a cosmic fire slowly fading into the night. White dwarfs are incredibly dense, packing the mass of a star into a volume no larger than a planet. a single teaspoon of white dwarf material would weigh as much as an elephant here on Earth. Yet, despite their immense density, these stellar remnants are remarkably stable. They no longer burn with the fierce energy of their youth, but instead radiate a gentle, steady light as they cool over billions of years. The cooling process of a white dwarf is a slow and peaceful journey. Over time, the heat trapped within its core gradually escapes into the surrounding space, and the white dwarf dims, growing cooler and fainter. Imagine a glowing coal left to rest after a fire has burned out. Its light softens, its warmth fades, and eventually, it becomes a cold, dark remnant. This is the fate of a white dwarf, a quiet and gradual transition from a fiery star to a cold, dark object in the vastness of space. Yet, even in their fading light, white dwarfs hold a profound significance. They are the final resting place of stars that once illuminated the cosmos, and they serve as a reminder of the delicate balance that governs the lives of stars. As we observe these quiet embers, we are reminded of the enduring nature of the universe, where even in endings, there is a sense of peace and continuity. With the story of white dwarfs now unfolding before us, we prepare to explore the next chapter in the life cycle of stars, a chapter marked by immense power, explosive endings, and the birth of some of the most mysterious objects in the cosmos. Now, as we turn our gaze to the heavens, we encounter the true titans of the cosmos, supergiants. These colossal stars are the giants among giants, dwarfing even the brightest stars we know. Imagine a star so immense that if it were placed at the center of our solar system, its outer layers would stretch far beyond the orbit of Jupiter. Supergiants are not just large, they are luminous beyond measure, shining with a brilliance that can outshine entire galaxies of smaller stars. Unlike the steady, enduring glow of stars like our sun, supergiants burn with an intensity that is both awe-inspiring and fleeting. Their lives are marked by a fiery urgency as they consume their nuclear fuel at an astonishing rate. While a star like the sun may shine steadily for billions of years, a supergiant lives fast and dies young, its lifespan measured in mere millions of years. This rapid consumption of energy gives supergiants their extraordinary brightness, but it also seals their fate, leading them toward an explosive and dramatic end. The sheer size of a supergiant is almost beyond comprehension. Some of these stars are hundreds of times more massive than the sun, and their surfaces glow with temperatures far hotter than anything we experience in our solar neighborhood. Their light, often tinged with hues of blue or red depending on their temperature, paints the cosmos with a palette of celestial beauty. Yet, beneath this dazzling exterior lies a core under immense pressure, where the forces of gravity and nuclear fusion wage a constant battle. Supergiants are not just stars, they are cosmic powerhouses, shaping the universe around them. Their intense radiation and stellar winds carve out vast regions of space, influencing the birth of new stars and the formation of planets. Even in their relatively short lives, supergiants leave an indelible mark on the cosmos, their light traveling across the universe long after they have faded from view. As we marvel at the grandeur of these stellar titans, we are reminded of the incredible diversity and dynamism of the universe. Supergiants stand as a testament to the extremes of nature, where beauty and power coexist in a delicate balance. And as we prepare to explore the next chapter in their story, we find ourselves on the brink of one of the most dramatic events in the cosmos, the explosive end of a supergiant's life. Now, as we step into the final act of a supergiant's life, we witness one of the most breathtaking and powerful events in the universe, a supernova. This is not just the death of a star, it is a cosmic spectacle, a brilliant explosion that outshines entire galaxies for a brief moment in time. Imagine the energy of billions of stars unleashed in a single, dazzling burst, lighting up the darkness of space with a brilliance that can be seen across unimaginable distances. At the heart of this explosion lies the core of the supergiant, where the forces of gravity and nuclear fusion have reached their breaking point. For millions of years, the star has burned through its fuel, fusing lighter elements into heavier ones. But now, as it exhausts its final reserves, the core collapses under its own weight. In an instant, the star's outer layers are hurled outward in a cataclysmic explosion, scattering stardust and energy across the cosmos. The energy released in a supernova is almost beyond comprehension. For a brief moment, the star shines brighter than all the other stars in its galaxy combined. This explosion creates shock waves that ripple through space, compressing nearby gas and dust and triggering the birth of new stars. It is a cosmic cycle of destruction and creation, where the death of one star gives life to countless others. But a supernova is more than just a dazzling light show. It is also a cosmic forge, where the heaviest elements in the universe are born. In the intense heat and pressure of the explosion, atoms are fused together to form elements like gold, silver, and uranium. These elements are scattered into space, eventually becoming part of new stars, planets, and even life itself. Every atom in your body, every piece of jewelry you wear, and every breath you take contains elements forged in the heart of a dying star. As the light of the supernova fades, it leaves behind a glowing remnant, a nebula filled with swirling gas and dust, illuminated by the energy of the explosion. This remnant is a cosmic memorial, a reminder of the star's fiery end and the beauty that can emerge from destruction. The story of a supernova is one of both awe and reflection. It reminds us of the incredible power and fragility of the universe, where even the mightiest stars must one day come to an end. Yet, in their final moments, they leave behind a legacy that shapes the cosmos for eons to come. And as we prepare to explore what remains after the explosion, we find ourselves drawn to the mysterious remnants that linger in the aftermath: neutron stars and black holes, the next chapters in this cosmic journey. As the echoes of the supernova fade, we turn our gaze to what remains in the aftermath: neutron stars. These are the dense, mysterious cores left behind after the explosive death of a massive star. Imagine compressing the mass of our sun into a sphere no larger than a city. That is the astonishing density of a neutron star, where matter is packed so tightly that a single teaspoon would weigh billions of tons on Earth. Neutron stars are born from the collapse of a supergiant's core, where gravity crushes protons and electrons together to form neutrons. This process creates an object so dense that it defies imagination. But what makes neutron stars truly fascinating is their behavior. They spin at incredible speeds, some rotating hundreds of times per second. This rapid rotation generates powerful magnetic fields, trillions of times stronger than Earth's, which can create beams of radiation that sweep across the cosmos like cosmic lighthouses. These beams, known as pulsars, are one of the most striking features of neutron stars. As the star spins, its beams of light and radiation flash across the universe in a rhythmic, pulsating pattern. This steady beat, like the ticking of a cosmic clock, allows astronomers to detect and study these distant objects. The regularity of their pulses is so precise that some pulsars rival atomic clocks in accuracy, making them invaluable tools for understanding the universe. But neutron stars are not just cosmic timekeepers. They are also laboratories for extreme physics. The intense gravity and magnetic fields create conditions that cannot be replicated on Earth, offering insights into the nature of matter and the forces that govern the universe. In their cores, matter may exist in states so strange that they challenge our understanding of physics, with exotic particles and phenomena that remain a mystery. As we explore these dense remnants, we are reminded of the incredible resilience of the universe. Even in the aftermath of a star's violent death, something extraordinary emerges: a neutron star, spinning with precision and radiating energy into the void. These objects are not just remnants of destruction, they are beacons of cosmic order, pulsating with the rhythm of the universe itself. And as we prepare to delve deeper into the mysteries of the cosmos, we find ourselves drawn to the most enigmatic of all stellar remnants: black holes, where gravity's grip is so strong that not even light can escape. But that is a story for another moment, as we continue our journey through the life and death of stars. Now, as we venture further into the depths of the cosmos, we encounter one of the most mysterious and awe-inspiring phenomena in the universe: black holes. Born from the remnants of the most massive stars, black holes are the ultimate expression of gravity's power. When a star many times more massive than our Sun exhausts its fuel, its core collapses under its own weight, creating a gravitational force so intense that not even light can escape its grasp. This is the birth of a black hole, a region of space where the laws of physics as we know them begin to break down. At the heart of a black hole lies the singularity, a point of infinite density where matter is crushed to an unimaginable degree. Surrounding it is the event horizon, the boundary beyond which nothing can return. Once something crosses this threshold, it is lost to the universe forever, pulled inexorably toward the singularity. This makes black holes cosmic abysses, swallowing everything that comes too close, from stars and gas to even light itself. Yet, despite their destructive reputation, black holes are also windows into the unknown. Their extreme conditions challenge our understanding of physics, offering clues about the nature of space, time, and gravity. For instance, Einstein's theory of general relativity predicts that black holes warp the fabric of space-time, creating distortions that can bend light and slow time itself. Near a black hole, the universe behaves in ways that seem almost magical, defying our everyday experiences. Black holes also play a crucial role in shaping the cosmos. Supermassive black holes, millions or even billions of times more massive than our Sun, reside at the centers of galaxies, including our own Milky Way. These colossal entities influence the motion of stars and gas, driving the evolution of galaxies over billions of years. They are not just destroyers, but also creators. Their immense energy, fueling the birth of new stars and shaping the structure of the universe itself. But perhaps the most intriguing aspect of black holes is the mystery they hold. What lies beyond the event horizon? What happens to matter as it approaches the singularity? These questions remain unanswered, tantalizing scientists and sparking the imagination of dreamers. Black holes remind us that the universe is full of wonders we have yet to understand, inviting us to explore the boundaries of knowledge and imagination. As we contemplate these cosmic enigmas, we are drawn to the next chapter in the story of stars, stellar recycling, where the elements forged in the hearts of stars are scattered across the cosmos, giving rise to new stars, planets, and even life itself. But for now, let us linger in the shadow of the black hole, marveling at its power and mystery, a reminder of the infinite complexity of the universe. As we step away from the shadowy depths of black holes, we find ourselves in the midst of a cosmic dance that has been unfolding since the dawn of the universe, stellar recycling. This is the process by which the elements forged in the hearts of stars are scattered across the cosmos, creating the building blocks for new stars, planets, and even life itself. It is a cycle as old as time, a testament to the eternal nature of the universe. When a star reaches the end of its life, whether through a gentle shedding of its outer layers or a cataclysmic supernova explosion, it releases the elements it has created during its lifetime. These elements, from the lightest hydrogen to the heaviest metals, are flung into the vastness of space, carried by stellar winds and shock waves. Over time, they mingle with the interstellar medium, the thin soup of gas and dust that fills the galaxy. This cosmic material, enriched by the remnants of countless stars, becomes the raw material for new stellar nurseries. Gravity begins to pull these clouds of gas and dust together, igniting the process of star formation once again. In this way, the life cycle of stars is a continuous loop, a circle of cosmic life that ensures the universe is never static, but always evolving. The elements created in stars are not just the building blocks of new stars, they are also the ingredients for planets and, ultimately, life. Carbon, oxygen, nitrogen, and other essential elements are forged in the cores of stars and scattered across the galaxy. When new stars and planets form, these elements become part of their composition, creating the conditions necessary for life to emerge. Every atom in your body, every breath you take, was once part of a star, a reminder of our deep connection to the cosmos. This process of stellar recycling is not just a scientific concept. It is a poetic reminder of the interconnectedness of all things. The universe is a vast, ever-changing tapestry, woven together by the lives and deaths of stars. Each star that shines in the night sky is part of this grand cycle, a link in the chain that stretches back to the beginning of time and forward into the distant future. As we reflect on this eternal cycle, we are reminded that the universe is not just a collection of objects, but a living, breathing entity, constantly renewing itself. The elements that make up the stars, the planets, and even ourselves are part of a cosmic journey that has no end, a journey that continues to unfold with each passing moment. And now, as we turn our gaze to the next chapter in this cosmic story, we find ourselves drawn to the beauty of star clusters, communities of stars born from the same clouds of gas and dust, shining together in the vast expanse of space. But for now, let us linger in the wonder of stellar recycling, marveling at the timeless dance of creation and renewal that defines the universe. As we shift our gaze from the timeless cycle of stellar recycling, we find ourselves drawn to the breathtaking beauty of star clusters, communities of stars that shine together in the vast expanse of space. These clusters are more than just collections of stars. They are cosmic families, born from the same clouds of gas and dust, bound together by gravity and a shared origin. Imagine a night sky not just dotted with individual stars, but illuminated by dense gatherings of them, sparkling like diamonds scattered across velvet. These clusters come in two main types: open clusters and globular clusters. Open clusters are younger, looser groups of stars, often found in the spiral arms of galaxies. They are like siblings, born together and slowly drifting apart over time. Globular clusters, on the other hand, are ancient, tightly packed spheres of stars, some containing hundreds of thousands of members. These clusters are like grandparents, holding the secrets of the universe's earliest days. Star clusters are not just beautiful to behold, they are also invaluable to astronomers. Because all the stars in a cluster form from the same material at roughly the same time, they provide a unique laboratory for studying stellar evolution. By observing stars of different masses within a cluster, scientists can piece together how stars age and change over time. It's like watching a family photo album come to life, with each star representing a different stage of life. The sense of togetherness in star clusters is profound. These stars are not isolated, they are part of a community, influencing one another through their gravitational pull and shared environment. Some clusters even contain binary stars, pairs that orbit each other in a celestial dance, further emphasizing the interconnectedness of these cosmic families. As we marvel at the beauty and significance of star clusters, we are reminded of the unity that exists in the universe. Just as stars are born together and shine as one, we too are part of a larger cosmic story, connected by the very elements that make up the stars. And now, as we prepare to explore the fascinating dynamics of binary stars, let us carry with us the image of these stellar communities, a reminder of the harmony and togetherness that define the cosmos. Now, as we turn our attention to the skies, let us step into the mesmerizing world of binary stars, where two stars are locked in an eternal cosmic dance. These stellar pairs, bound together by gravity, orbit a shared center of mass, creating a delicate balance that has fascinated astronomers for centuries. Picture two partners on a grand stage, moving in perfect harmony, their paths intertwined in a ballet that spans millions of years. Binary star systems come in many forms. Some stars orbit each other so closely that they complete a full cycle in just a few days, while others are separated by vast distances, taking centuries to complete a single orbit. In some cases, the stars are so close that they share material, with one star pulling gas from its companion in a process called mass transfer. This can lead to spectacular events, such as novas or even the formation of exotic objects like neutron stars or black holes. The interactions between binary stars can also create unique phenomena. For instance, when one star in a binary system is a white dwarf, it can accumulate enough material from its companion to trigger a thermonuclear explosion, lighting up the night sky as a nova. In other cases, the gravitational pull between the stars can distort their shapes, causing them to stretch and warp as they orbit each other. These distortions can lead to the emission of gravitational waves, ripples in space-time that carry energy away from the system. Binary stars are not just fascinating to observe, they also play a crucial role in our understanding of the universe. By studying their orbits, astronomers can measure the masses of the stars involved, providing valuable data for testing theories of stellar evolution. Binary systems also serve as natural laboratories for studying the effects of gravity and the behavior of matter under extreme conditions. As we marvel at the intricate dynamics of binary stars, we are reminded of the interconnectedness of the cosmos. These celestial companions, locked in their eternal dance, are a testament to the harmony and balance that pervade the universe. And now, as we prepare to explore the rhythmic pulsations of variable stars, let us carry with us the image of these cosmic partners, a reminder of the beauty and complexity that define the stellar world. Now, as we shift our gaze to the ever-changing lights of the cosmos, we encounter the captivating world of variable stars. These celestial bodies are not constant in their brilliance. Instead, their brightness ebbs and flows over time, creating a rhythmic dance of light that has intrigued astronomers and stargazers alike. Imagine a star that breathes, its glow rising and falling like the gentle waves of an ocean, a cosmic heartbeat echoing through the vastness of space. Variable stars come in many forms, each with its own unique pattern of change. Some, known as pulsating variables, expand and contract in size, causing their brightness to vary in a regular cycle. These stars, like the famous Cepheid variables, serve as cosmic lighthouses, their pulsations helping astronomers measure distances across the universe. Others, called eclipsing binaries, are pairs of stars that orbit each other in such a way that one periodically blocks the light of the other, creating a rhythmic dimming and brightening as seen from Earth. Then there are the cataclysmic variables, stars that undergo sudden and dramatic changes in brightness due to explosive events. These can include novas, where a white dwarf star pulls material from a companion until it ignites in a brilliant flash, or even more extreme events like supernovas, where a massive star ends its life in a spectacular burst of energy. Each type of variable star tells a story, revealing the dynamic and ever-changing nature of the universe. The reasons behind these fluctuations are as varied as the stars themselves. For pulsating variables, the changes are driven by internal processes, as the star's outer layers expand and contract under the influence of gravity and pressure. In eclipsing binaries, the variations are caused by the geometry of their orbits, as one star passes in front of the other, and for cataclysmic variables, the changes are the result of explosive interactions between stars, a reminder of the powerful forces at work in the cosmos. As we observe these pulsating lights, we are reminded of the rhythm and flow that permeate the universe. Variable stars, with their ever-changing brilliance, offer a glimpse into the dynamic processes that shape the lives of stars. And now, as we prepare to explore the gentle breezes of stellar winds, let us carry with us the image of these rhythmic celestial dancers, a testament to the beauty and complexity of the stellar world. Now, as we drift further into the cosmic tapestry, let us turn our attention to the subtle yet powerful forces known as stellar winds. These are not the winds we feel on Earth, but rather streams of charged particles, protons, electrons, and heavier elements that flow outward from the surface of stars, carried by the immense energy of their cores. Picture a star not just as a glowing orb of light, but as a source of an invisible, gentle breeze that travels across the vastness of space, shaping the environment around it. Stellar winds are born from the intense heat and pressure within a star. As nuclear fusion ignites in the core, it generates not only light, but also a tremendous amount of energy. This energy pushes particles outward, creating a flow that escapes the star's gravitational pull. In smaller stars like our Sun, these winds are relatively calm, a steady stream that flows outward in all directions. But in massive stars, the winds can be fierce, carrying away vast amounts of material at incredible speeds. These cosmic breezes play a crucial role in shaping the universe. As stellar winds travel through space, they interact with the surrounding gas and dust, carving out cavities and influencing the formation of new stars and planets. In some cases, they can even trigger the collapse of nearby gas clouds, setting the stage for the birth of new stellar systems. Over time, the material carried by these winds becomes part of the interstellar medium, the vast reservoir of gas and dust that fills the space between stars. The effects of stellar winds are not limited to their immediate surroundings. In binary star systems, where two stars orbit each other, the winds from one star can collide with those of the other, creating shock waves and heating the surrounding gas to extreme temperatures. These interactions can produce stunning visual displays, such as glowing nebulae and intricate patterns of light and shadow. As we reflect on the gentle yet profound influence of stellar winds, we are reminded of the interconnectedness of the cosmos. These invisible streams, flowing silently through the void, carry with them the building blocks of new worlds and the echoes of stellar life. And now, as we prepare to explore the cosmic tremors known as starquakes, let us carry with us the image of these gentle breezes, a testament to the quiet yet enduring forces that shape the universe. Now, as we venture deeper into the mysteries of the cosmos, let us turn our gaze to the enigmatic phenomenon known as starquakes. These are not the quakes that shake the Earth, but rather cosmic tremors that ripple across the surface of neutron stars, the dense remnants of massive stars that have ended their lives in spectacular supernova explosions. Imagine a star so dense that a single teaspoon of its material would weigh billions of tons. Now, picture the surface of such a star shifting, cracking, and releasing bursts of energy that send shockwaves through the fabric of space itself. Starquakes occur when the crust of a neutron star, a layer only a few kilometers thick but incredibly rigid, undergoes sudden adjustments. These shifts are caused by the immense gravitational forces and magnetic fields that warp the star's surface over time. As the crust cracks and settles, it releases energy in the form of X-rays and gamma rays, creating flashes of light that can be detected across vast distances. These events are rare and fleeting, but they offer astronomers a glimpse into the extreme conditions that exist on these exotic stellar remnants. The energy released during a starquake is staggering. In mere seconds, a single tremor can unleash more energy than our sun emits in thousands of years. Yet, despite their power, these cosmic tremors are not chaotic or destructive in the way we might imagine. Instead, they are a natural part of the life of a neutron star, a way for the star to release built-up stress and stabilize itself. It's as if the star is sighing, letting go of the tension that has accumulated over time. What makes starquakes even more fascinating is their connection to the magnetic fields of neutron stars. These fields are among the strongest in the universe, trillions of times more powerful than Earth's magnetic field. When a starquake occurs, it can cause the magnetic field to shift, creating ripples that travel through space. These ripples, known as magnetar flares, are some of the most energetic events in the universe, capable of affecting distant regions of space and even disrupting satellite communications on Earth. As we contemplate the quiet yet powerful nature of starquakes, we are reminded of the delicate balance that exists in the cosmos. Even in the most extreme environments, there is a rhythm, a pattern to the chaos. These cosmic tremors, though rare and fleeting, are a testament to the dynamic and ever-changing nature of the universe. And now, as we prepare to explore the invisible forces of stellar magnetism, let us carry with us the image of these gentle yet profound tremors, a reminder of the hidden energies that shape the stars. Now, as we shift our focus to the unseen forces that shape the cosmos, let us explore the invisible yet powerful phenomenon of stellar magnetism. Stars, much like our own sun, are not just glowing spheres of gas. They are also dynamic entities with magnetic fields that play a crucial role in their behavior and the space around them. These magnetic fields, though invisible to the naked eye, are among the most influential forces in the universe, shaping the lives of stars and the environments they inhabit. The magnetic fields of stars are generated deep within their cores, where the intense heat and pressure create a swirling, turbulent sea of charged particles. As these particles move, they generate electric currents, which in turn produce magnetic fields. This process, known as the dynamo effect, is similar to how Earth's magnetic field is created, but on a much grander scale. The result is a magnetic field that can extend far beyond the star itself, influencing everything from its surface to the surrounding space. One of the most striking effects of stellar magnetism is seen in sunspots, those dark patches that occasionally appear on the surface of stars like our sun. These spots are regions where the magnetic field is particularly strong, inhibiting the flow of heat and causing the area to cool and darken. Sunspots are just one example of how magnetic fields can shape the appearance and behavior of stars, creating patterns and phenomena that astronomers can observe and study. But the influence of stellar magnetism goes far beyond sunspots. In some stars, particularly those with extremely strong magnetic fields, these forces can shape the star's entire atmosphere. For instance, in magnetars, a type of neutron star with an incredibly powerful magnetic field, the magnetic forces are so intense that they can twist the star's crust, leading to the starquakes we discussed earlier. These magnetic fields can also accelerate particles to nearly the speed of light, creating bursts of radiation that can be detected across the galaxy. Even more fascinating is the role of magnetic fields in the birth and death of stars. In stellar nurseries, magnetic fields can influence how gas and dust collapse to form new stars, guiding the flow of material and shaping the structure of the emerging star system. And when a star reaches the end of its life, its magnetic field can play a crucial role in determining how it sheds its outer layers, whether through a gentle planetary nebula or a violent supernova explosion. As we ponder the invisible yet profound influence of stellar magnetism, we are reminded of the intricate and interconnected nature of the universe. These magnetic fields, though unseen, are a vital part of the cosmic dance, shaping the lives of stars and the environments they create. And now, as we prepare to explore the eternal cycle of stellar death and rebirth, let us carry with us the image of these invisible forces, a reminder of the hidden energies that guide the stars on their journey through time. As we turn our gaze to the grand tapestry of the cosmos, we find ourselves drawn to the eternal rhythm of stellar death and rebirth. This cycle, as old as the universe itself, is a testament to the timeless nature of creation and transformation. Stars, those luminous beacons of light, are born from the dust of their predecessors, live out their lives in a delicate balance of forces, and eventually return their essence to the cosmos, only to begin anew. Imagine for a moment the life of a star as a cosmic dance, a choreography of gravity, heat, and light. It begins in the quiet depths of a stellar nursery, where clouds of gas and dust slowly coalesce under the gentle pull of gravity. Over millions of years, these clouds grow denser and hotter until the spark of nuclear fusion ignites and a new star is born. This star will shine for billions of years, its light a steady presence in the vast expanse of space. But even stars, with their seemingly eternal glow, are not immortal. As they age, they exhaust their fuel, and the delicate balance that sustained them begins to falter. For smaller stars, this means a gradual expansion into a red giant, followed by a gentle shedding of their outer layers, leaving behind a glowing planetary nebula and a cooling white dwarf. For more massive stars, the end is far more dramatic, marked by a cataclysmic supernova explosion that scatters their remains across the galaxy. Yet even in death, stars give life. The elements forged in their cores, carbon, oxygen, iron, and more, are flung into the void, seeding the cosmos with the building blocks of new stars, planets, and even life itself. These elements, born in the hearts of stars, become the raw materials for the next generation of stellar nurseries, continuing the cycle of birth, life, and death. This eternal cycle is a reminder of the interconnectedness of all things in the universe. The atoms that make up our world, the air we breathe, the ground beneath our feet, all were once part of a star, born in the fiery crucible of stellar fusion. As we contemplate this cosmic dance, we are reminded of our own place in the universe, a small but integral part of this grand, timeless cycle. And so, as we prepare to explore the next chapter in our journey through the cosmos, let us carry with us the image of this eternal cycle, a reminder of the beauty and mystery that lies at the heart of the universe. The stars may fade, but their legacy endures, a testament to the enduring power of creation and the infinite possibilities that lie ahead. Now, as we shift our gaze closer to home, let us explore the Milky Way, the galaxy that cradles our solar system and countless other stars. This vast, swirling expanse of light and dust is more than just a backdrop to the night sky. It is our galactic home, a place where billions of stars, including our sun, are born, live, and die. The Milky Way is a barred spiral galaxy, a cosmic pinwheel with arms that stretch outward from a bright, dense core. These arms are filled with stars, gas, and dust, creating a tapestry of light that has inspired wonder for millennia. At the heart of the Milky Way lies its center, a region teeming with activity. Here, stars orbit a supermassive black hole, their paths shaped by its immense gravitational pull. This central hub is a place of extremes, where stars are born in frenzied bursts, and where the remnants of ancient stellar explosions linger. Yet, despite its intensity, the core is just one part of the galaxy's intricate structure. Surrounding it are the spiral arms, where stars like our sun reside. These arms are like cosmic neighborhoods, each with its own rhythm and character, yet all connected by the shared story of the galaxy. Our sun, a modest star by cosmic standards, sits in one of these arms, known as the Orion Arm. From here, we look out across the galaxy, seeing its disk edge on as a faint band of light stretching across the night sky. This band, the Milky Way's namesake, is a reminder of our place within this vast system. It is a view that has guided travelers, inspired poets, and sparked the curiosity of scientists for centuries. Stars play a vital role in the Milky Way's story. They are not just points of light, but the building blocks of the galaxy itself. Through their life cycles, stars create and distribute the elements that form planets, moons, and even life. They light up the galaxy, shaping its structure and influencing its evolution. And as they die, they return their essence to the cosmos, ensuring that the cycle of creation continues. The Milky Way is more than just a collection of stars. It is a living, breathing entity, a place where the past, present, and future of the universe converge. It is a reminder that we are part of something much larger, a cosmic community that stretches across time and space. As we gaze up at the night sky, we are not just observers but participants in this grand story, connected to the stars in ways both profound and beautiful. And so, as we continue our journey through the cosmos, let us carry with us the warmth and familiarity of our galactic home, a place where the mysteries of the universe feel just a little closer to home. As we venture beyond the familiar glow of our sun, a new frontier of discovery unfolds: exoplanets, worlds that orbit distant stars. These celestial bodies, once the stuff of science fiction, are now a reality, revealing the incredible diversity of planets scattered across the cosmos. From scorching hot gas giants to rocky, Earth-like worlds, exoplanets come in all shapes and sizes, each with its own unique story to tell. The first confirmed exoplanet, it was discovered in the early 1990s, and since then, thousands more have been found, each one expanding our understanding of the universe and our place within it. Some exoplanets orbit their stars so closely that their surfaces are molten, while others drift in the cold, dark reaches of space, far from any warmth. There are planets with skies filled with swirling clouds of molten metal, and others where the atmosphere is so thick it rains glass. Yet among these extremes, there are also worlds that seem eerily familiar, planets with conditions that might just support life. These Earth-like exoplanets, often referred to as Goldilocks planets, orbit within the habitable zone of their stars, where temperatures are just right for liquid water to exist. Water, as we know, is the key ingredient for life, as we understand it, and the discovery of these worlds ignites hope that we are not alone in the universe. The search for exoplanets has also revealed systems unlike anything in our solar system. Some stars host multiple planets, orbiting in tight, intricate patterns, while others have planets that wander alone, untethered to any star. There are even rogue planets, drifting through the void of space, untethered to any star, their surfaces frozen and dark. Each discovery challenges our assumptions and invites us to imagine the possibilities. Could there be life on these distant worlds? Could they have oceans, forests, or even civilizations? While we may not yet have the answers, the very existence of exoplanets reminds us that the universe is vast, mysterious, and full of potential. As we continue to explore these distant worlds, we are not just uncovering new planets, we are uncovering new possibilities. The study of exoplanets is a journey of hope, a reminder that the universe is far more diverse and wondrous than we ever imagined. It is a journey that invites us to dream, to wonder, and to imagine what might lie beyond the next star. And as we gaze out into the cosmos, we are reminded that the search for exoplanets is not just a scientific endeavor. It is a quest to understand our place in the universe and to discover whether, somewhere out there, another world might be looking back at us. As we shift our gaze from the wonders of distant worlds, let us now turn to the stars themselves, not just as celestial bodies, but as keepers of time. Stars, in their steady glow and predictable cycles, act as natural clocks, helping astronomers unravel the age of the universe itself. Each star tells a story, not just of its own life, but of the vast stretches of time that have passed since its birth. Take, for example, the life cycle of a star. From the moment it ignites in a stellar nursery to its final stages as a white dwarf, neutron star, or black hole, a star's journey is marked by distinct phases, each with its own timeline. By studying these phases, astronomers can estimate the age of stars and, in turn, piece together the history of the cosmos. One of the most reliable stellar timekeepers is the main sequence phase, where stars spend the majority of their lives. During this period, stars burn hydrogen in their cores, shining steadily for billions of years. The length of this phase depends on a star's mass. Smaller stars, like red dwarfs, burn their fuel slowly and can last for trillions of years, while massive stars burn brightly but briefly, living only a few million years. By observing where a star is in its life cycle, scientists can calculate its age and, by extension, the age of the star clusters or galaxies it belongs to. But stars do more than just mark their own lifetimes. They also help us measure the age of the universe. The oldest stars, found in globular clusters, are like ancient relics, their light carrying the echoes of the early universe. By determining the ages of these stars, astronomers can estimate the minimum age of the cosmos. Current estimates suggest the universe is around 13.8 billion years old, a number derived in part from the study of these ancient stellar timekeepers. Even the remnants of stars play a role in this cosmic clockwork. White dwarfs, the cooling embers of stars like our sun, gradually fade over billions of years. By measuring their temperature and brightness, astronomers can estimate how long they have been cooling, providing another way to gauge the passage of time on a cosmic scale. Stars, in their quiet, rhythmic existence, remind us that time is not just a human construct, but a fundamental aspect of the universe. They are the heartbeat of the cosmos, their lives and deaths marking the eons that have shaped the universe we see today. As we continue to study these celestial timekeepers, we gain not just a deeper understanding of the stars themselves, but of the grand, unfolding story of the universe. And now, as we look ahead, we turn our attention to the future of stars, what lies ahead for these luminous giants as the universe continues to evolve. As we peer into the vast expanse of the cosmos, we find ourselves contemplating the future of stars, what lies ahead for these luminous giants as the universe continues its slow, inevitable march through time. Stars, those brilliant beacons of light, have illuminated the universe for billions of years, but even they are not eternal. Their futures are as varied as their forms, shaped by their masses, their environments, and the relentless passage of time. For the smallest stars, like red dwarfs, the future is one of endurance. These dim, cool stars burn their fuel so slowly that they can shine for trillions of years, far longer than the current age of the universe. They are the marathon runners of the cosmos, their faint glow persisting long after larger stars have faded. Yet even they will eventually exhaust their fuel, cooling into dark, inert remnants that drift silently through the void. Medium-sized stars, like our sun, face a different fate. After billions of years of steady burning, they will swell into red giants, their outer layers expanding as their cores contract. Eventually, they will shed these layers, leaving behind a glowing planetary nebula and a dense white dwarf at its heart. Over eons, these white dwarfs will cool and dim, becoming faint embers that slowly fade into darkness. For the most massive stars, the future is one of drama and transformation. These titans burn through their fuel in mere millions of years, ending their lives in spectacular supernova explosions. From their ashes, neutron stars or black holes are born, objects so dense and powerful that they defy our understanding of physics. Neutron stars spin rapidly, their surfaces rippling with starquakes, while black holes warp the fabric of space and time, their gravitational pull so strong that not even light can escape. But what of the universe itself? As stars continue to form, burn, and die, the supply of gas and dust needed to create new stars will gradually dwindle. Over trillions of years, the rate of star formation will slow, and the universe will grow dimmer. The last stars will flicker out, leaving behind a cosmos populated by black holes, neutron stars, and cold, dark remnants. Even these remnants will not last forever. Over unimaginable timescales, black holes will evaporate through a process known as Hawking radiation, and the universe will enter a state of near-perfect darkness and stillness. Yet even in this distant future, the legacy of stars will endure. The elements forged in their cores, carbon, oxygen, iron, and more, will remain, scattered across the cosmos. These elements, the building blocks of planets, life, and even new stars, are the gifts of stars to the universe. They remind us that even as individual stars fade, their contributions to the cosmos are eternal. As we contemplate this distant future, we are reminded of the fleeting nature of light and life in the grand tapestry of the universe. Stars, in their brilliance and their eventual fading, teach us about the cycles of existence, birth, life, death, and renewal. They are a testament to the beauty and transience of all things, a reminder to cherish the light while it lasts. And so, as we gaze at the stars above, we are not just looking at distant suns, but at the echoes of the past and the whispers of the future, a cosmic story that stretches far beyond our own time. As we shift our gaze from the scientific to the symbolic, let us explore the rich tapestry of myths and legends that stars have inspired across cultures and centuries. For as long as humans have looked up at the night sky, stars have been more than just celestial bodies. They have been storytellers, guiding lights, and symbols of the divine. In ancient Greece, the stars were seen as the realm of gods and heroes. The constellation Orion, for example, was said to be a mighty hunter, placed among the stars by Zeus. His story, filled with bravery and tragedy, was immortalized in the heavens, a reminder of humanity's connection to the divine. Similarly, the Pleiades, a cluster of stars in the Taurus constellation, were believed to be 7 sisters transformed into stars to escape the pursuit of Orion. These tales not only entertained, but also served as moral lessons, teaching virtues like courage, loyalty, and humility. Moving to the east, Chinese mythology paints the stars as part of a grand celestial bureaucracy. The stars were seen as the homes of gods and spirits, each with its own role in maintaining the harmony of the universe. The story of the cowherd and the weaver girl, represented by the stars Altair and Vega, tells of 2 lovers separated by the Milky Way, allowed to meet only once a year on the 7th day of the 7th month. This tale, celebrated during the Kixi festival, speaks to themes of love, perseverance, and the enduring power of connection. In the Americas, indigenous cultures wove stars into their creation stories and spiritual practices. The Navajo people, for instance, saw the stars as the eyes of their ancestors, watching over them from the heavens. The constellation known as the Big Dipper was often associated with the Great Bear, a figure central to many Native American legends. These stories were not just myths, but living traditions, passed down through generations to teach respect for nature and the interconnectedness of all life. Even in modern times, stars continue to inspire. They appear in literature, art, and music, symbolizing hope, guidance, and the infinite possibilities of the universe. From Shakespeare's poetic references to the stars as fate's arbiters to Van Gogh's swirling masterpiece Starry Night, the celestial realm has captivated the human imagination. Today, stars still guide us not just as navigational tools, but as reminders of our shared humanity and the timeless stories that bind us together. As we reflect on these myths and legends, we are reminded that stars are more than just objects in the sky. They are mirrors of our hopes, fears, and dreams, reflecting the stories we tell about ourselves and our place in the cosmos. Through these tales, the stars become not just distant suns, but companions in our journey through life, lighting the way with their ancient wisdom and eternal glow. As we bring our journey through the life cycle of stars to a close, let us take a moment to reflect on the profound beauty and mystery that these celestial beings embody. From their birth in the swirling clouds of stellar nurseries to their final moments as fading embers or explosive supernova, stars remind us of the grandeur and intricacy of the universe. They are not just distant lights in the night sky, but storytellers, weaving tales of creation, transformation, and renewal that span billions of years. Stars teach us about the delicate balance of forces that shape existence: gravity, pulling inward, fusion, pushing outward, and the endless dance of energy and matter. They show us the diversity of the cosmos, from the quiet glow of red dwarfs to the fiery brilliance of supergiants, and in their death, they gift the universe with the building blocks of new stars, planets, and even life itself, ensuring that the cycle of creation continues. As you drift into sleep tonight, let the stars guide your dreams. Imagine the gentle glow of a newborn star, the steady light of a main sequence star, or the breathtaking beauty of a planetary nebula. Picture the vastness of the Milky Way, our galactic home, and the countless stars that illuminate its spiral arms. Let their timeless stories remind you of the infinite possibilities that lie within the cosmos and within yourself. The stars have been our companions since the dawn of humanity, lighting our way through the darkness and inspiring wonder in every generation. As you close your eyes, let their light carry you into a peaceful slumber, where the mysteries of the universe unfold in your dreams. Good night, and may the stars watch over you. Now, as we prepare to leave the stars behind and return to our own world, let's take a moment to connect. If this journey through the life and death of stars has sparked your curiosity or brought you peace, I'd love to hear your thoughts. Share your favorite part of this cosmic story in the comments below. Was it the birth of a star in a stellar nursery, the explosive beauty of a supernova, or the quiet glow of a white dwarf? Your reflections make this journey even more meaningful. If you've enjoyed drifting through the universe with me, consider subscribing to the channel. There are so many more cosmic sleep stories waiting to be explored, each one a new adventure through the wonders of space. And don't forget to hit the notification bell so you never miss a chance to dream among the stars. As you close your eyes tonight, let the stars guide your dreams. Imagine the infinite possibilities of the cosmos, the timeless dance of creation and renewal, and the gentle light of distant suns. Thank you for joining me on this journey through the life cycle of stars. Until next time, may the universe fill your dreams with wonder and peace. Good night.